Okay, guys, in today's lesson, we are going to be learning about similarity. So the first thing that we are going to talk about is how to solve each proportion. And I want you guys to remember that when there is a fraction bar, it's just another way to write divide. So right here in A, x is being divided by 8. So when I want to solve for x and I want to get x all alone, I need to undo that operation by multiplying by 8. I'm going to put it over 1 because I can always write a number over 1 to get that number. And then here these 8s cancel. So I can get 8 times 8 is 64 over 3 is equal to 8. And that's my answer there. On example B, we can do the same thing. So we're going to multiply both sides by 6 over 1, and we end up with 12/5 is equal to n. So far, pretty simple. It's not too bad. Now, when we get to the next one, this one's kind of tricky. We've got an x in the denominator. So when we have an x in the denominator, I can't just multiply it by 1 over 7. If I end up doing that, I get 6 over 35 is equal to 1 over x. But that doesn't really help me, so I don't want to do that. I can multiply both sides by x, because that'll get me the x on top, so I end up with 6x over 5 equals 7. And though that's solvable, I don't really like that way either. So one thing we can do is, you guys have maybe heard about, I know there's lots of different methods or directions to call this, but it's called cross multiplication. And it's where I'm going to take the 5 and the 7 and multiply them, and I'm going to take the 6 and the x and multiply them. But really, it's just a shortcut for what I'm going to show you right here. So what I would do is I'm going to first multiply everything by x over 1. And then I also want to clear this 5 right here. Let me highlight that in blue. I also want to clear the 5 so we don't have any fractions. So I'm also going to multiply everything by 5 over 1. So here, this 5 and this 5 cancel, and I end up with 6 times x, which is 6x. And on the right side of the equation, the x and the x cancel, so I end up with 7 times 5, which is 35. Then I can divide both sides by 6, and I get x equals 35 over 6. That would be the same thing right here. If I do 5 times 7, I end up with 35. And if I do x times 6, I end up with 6x. And as you can see, this expression and this expression are the same. So when I cross multiply, all I'm doing is clearing my fractions. So let's try to cross multiply with the next equation. So what I'm going to do is I'm going to multiply the 4 and the 6 to get 24. And then I'm going to multiply the 8 and the 3, or the 8 and the 3x to get 24x. Then to solve, I just divide both sides by 24, and I end up with x equals 1. When we get down into the next two, we can continue to do the same thing. So what I'm going to do is take the 1 times 4 and get a 4. And then I'm going to multiply the other direction. On this side, I'm going to write it this way as 12 times the quantity x plus 1, and I'm going to put that in parentheses. So the 12 times x is going to give us 12x. The 12 times the 1 gives us 12. The 4 is still on the left side. To solve, I minus 12 on both sides. I end up with negative 8 equals 12 over x. Then I can divide by 12. When I reduce that fraction, I end up with negative 2/3. Oh, this last one, it looks a little bit tricky. I've got x's kind of all over the place. but we can do the exact same process. So we are going to do, I'm going to change my color just so we can see this a little bit better. We're going to do 2 times 2x. That gives us 4x. And then on this side, we're going to do x minus 4 times x minus 6. And I just want to remind you that we learned when we're distributing, right? We can't just do the x times the x and the 4 times the 6. That's bad math. We can't do that. So we want to multiply our binomials, or we are going to just put it in our box real fast. So x times x is x squared, x times negative 4 is negative 4x, negative 6 times x is negative 6x, and negative 6 times negative 4 is 24x. No, it's just 24. Good catch if you caught me. Okay, so we're going to end up with x squared minus 10x plus 24. Then I want to go ahead and minus 4x on both sides. Because to solve a quadratic, I need to have it equal to 0, and I get x squared minus 10x plus 24. I'm going to move down into this next section just a little bit. So I need to find what are the factors that multiply to positive 24. Oh, heavens. 10 minus 4 is negative 14. We want to add to negative 14x. So we've got negative 2 and negative 12 are my factors there. So I end up with 0 equals x minus 2. Oh, let's give myself just a little more room. Oh, heavens. Let's go on that one. Okay, here we go. 0 equals x minus 2 times x minus 12. Then I make my 2 little equations to solve. And here, because it's a quadratic or a parabola, we're going to have 2 answers. So we get x is equal to 2 and 12. And I can make that box be, oh look, that fun little character showed up. Okay, there's my box there. All right. Then you can go ahead and look at these 2 triangles. And when I taught this lesson for my B7 class today, this is what they have noticed, that triangle ABC is equal to half of triangle DEF. So this triangle is half of this triangle. The other thing is that because of this and these symbols right here, that is showing us that all 3 of our angles are congruent. So I have 3 congruent angles. All right, so what does all this mean? Well, let's talk about what the definition of a dilation is. So a dilation, you learned about it last year, but it means that we are changing the size of an object without changing the shape. So we just want to make sure that if we're dilating something, that if it's a triangle, it stays a triangle, and if it's a circle, it stays a circle, and if it's a square, it stays a square, and it doesn't change shape. So to figure those out, all we do is we need to figure out what our 3 points are. We have an S, an R, and a T in this graph. Well, my S is at the point -1, 2. My R is at the point 1, 0. And my T is at the point 0, -2. I'm going to take all of those and multiply them by 2. So every single one of those numbers we're going to multiply by 2. So my S prime, my new S, is -2, 4. My R prime, or new R, in fact, let me, just for some ease, let's write this in just a different color. See if I can make it make a little more sense to you. Okay, S prime is -2, 4. R prime is 2, 0. I'm just taking every single number in the points and multiplying it by 2. That is our scale factor. So then I'm going to go to -2, 4 up here. That's my new S prime. R goes to 2, 0. He comes here. And T is at 0, -4. He comes here, and we can connect our dots. It was about the origin because we took the main point right here at the origin and just made the triangle bigger around it. That's all that at the origin means. All right, we're going to skip example B for a second, and we're going to move on to example C. So on example C, I have L, if I can be in the right color, I have L, I have M, and I have N. L is at 2, 0. M is at -1, 3. And N is at 0, 2. And right here it tells me I want a dilation of 1/4. So I'm going to multiply all of these things by 1/4. Well, 2 times 1/4 ends up being 1/2. And 0 times a fourth is still 0. M is -1/4, 3/4. N prime is 0, 1/2. So we go to 1/2, 0, which is right there. That's our new L point. M is -1/4, 3/4, so somewhere in there. Let me write that a little more legibly. That's our over 1/4, up 3/4. It's okay if we're not perfect. And then 0. Oh, that's a -2. It's a good thing I caught myself. This is a -2 right here. So we want this to be a -1/2. I need to come down here. That's our N prime and our little tiny triangle in there. It got smaller. So what does this show us? Well, we've already done this. We're going to skip this part too. I already had you write out the points. You do it the exact same way. You just write out the points yourself. So based on these problems, this is what we learned. An enlargement is where K, or the scale factor, is greater than 1. So when we did our dilation of 2 about the origin, our shape got larger. A reduction is where K, or our scale factor, is less than 1. So on this one where we had our 1/4, it was less than 1 and our shape got smaller. So why am I... Oh, we're not there yet. Okay, so we're going to find the scale factor of all of our shapes. So we have to look at the triangle and say, all right, this long side is 24, and this longest side doesn't have anything to make my scale factor. That doesn't really help me. 14 is my next shortest side, so that goes with 18. Okay, and 21 goes with 12. So I can use any of those to make my scale factor, and they will be the same. So I want to make sure when I'm doing my scale factor that the new shape, this is the new one because it says on the left to the right. So this is the second shape and this is the first shape. So my 21 is going to be divided by 12. Oh, I wrote 21 again. It's divided by 12, which should be equal to 18 divided by 14. And let's just double check that in the calculator. Did I do that wrong? 21. You know what? It's okay. I have done some wrong math, but that's okay. So we just need to put two of them together. Let's do our 18 divided by our 14. And that would be our scale factor right there. We can do it with our other shapes. The easiest one to see is the longest side of this one is the 28. The longest side of that one is the 20. Or sorry, that's a 7. So we can do new 7 over old 28 And this side is 20 and this side is 5. So that would be 5 over 20. Oh, and there our math is correct. They are 1/4. All right, let's not worry about this one where our math was wrong. That's how we set up a scale factor. And you can use scale factor in Similarity, which is the very next thing that we're going to talk about. So for things that are to be similar, 2 things must happen. First, the corresponding angles have to be congruent. And we're going to talk more about that in our next lesson. But just know that if it tells you the shapes are similar, their corresponding angles are going to be congruent. 2, and this is what we're going to work with today, the ratios of the lengths of their corresponding sides are equal. And that's exactly what we saw here. So maybe those first ones that we were setting up a ratio for weren't similar. Okay, the next part is just telling us how to write a similarity statement, and all it's saying is that we're going to put the pieces of the triangle with the pieces of the triangle. So K is going to match with K, and you can see that because right here I have 2 lines and right here I have 2 lines, little arc lines. L is going to match with L is going to match with Q, so here I have 3 lines and here I have 3 lines. And lastly, M is going to match with R. So I'm going to go ahead and put a little 1 arc line with M and R. I can also do the same thing for the sides. So when I match up my sides, KL is going to match with KQ. So we're going to call KL side number 1. And KQ also side number 1 so that we know that those match up. Now, LM is going to match with QR. So L to M I'm going to call side 2, and Q to R I'm going to call side 2. And lastly, we have these kind of this one K and this one M, and that's side 3, and Q, K, and R, and that's side 3. We're not going to go ahead and do these other examples. I have a faith that you guys can match those up yourself. If you would like to see how they match, if you're a little bit confused, go ahead and look at the notes key. And you can use scale factor, but we're going to find stuff a different way. All right, let's do a couple of examples. So this tells us, given the 2 figures are similar, find the missing length. So I can use this triangle to match up the pieces, just like I did up above. So we are going to match them this way. So JK is going to go with TU. I'm going to take my green. So JK, this is side number 1, is going to go with TU. All right, so 54 is going to match up with X because I don't know what this side is. And we're going to do equals. Okay, the next one is KL and UV. KL right here is a 90, so he's side number 2, and UV is side number 2 is 12. Well, right here in my proportion, I put the 54 on top. And the 54 is part of this triangle. So I need to make sure that this right here is this part of my triangle so that I have both of the tops put together in the same place. So we're going to put 90 there. And then the 12 is going to go on the bottom. Now, just like we were doing in our proportions in the beginning, we are going to cross multiply. So we are going to do 54 times 12. So we get 648 is equal to 90x. And then I'm going to divide both sides by 90. And I end up with x is equal to, what did I do? JK, you get to see me struggle just a minute. Okay, can you see what I did? Oh, I hope that there are some of you pointing out some errors that I made. Let's try this example again. All right, let's go back to our similarity statement. I set it up wrong. JK is this side, isn't it, guys? And TU is this side. Oops. All right, so I need to put my 90 with my x. All right, and that is going to be equal to, or KL is our other side. So KL is our 2, and UV is our 2. I sure hope that enough of you are paying attention to see that. So 90 matches with our 54. So let's highlight that in yellow again. So 90 goes on top, so we're going to want our yellow one to hit in that spot. So we're going to put our 54 there. And then our x goes with 12. All right, this is going to give us a better answer. So 90 times 12 is 1,080, which is equal to 54x. And then we get x equals 20. That looks like a better answer. All right, let's try this one more time. Okay, UV. Let's make him green. UV, and I'm going to highlight him this way so I don't do them wrong this time. UV goes with UK. Okay, those two match. Now let's highlight VW. VW is, I'm on the eraser. VW is here. KL is here. And then I can go ahead and make these purple sides be the last sides, and now I know what matches with what. And then I'm going to go ahead and highlight in yellow the 18 and the question mark so I can make sure that they go together on the same side. So I'm going to do 18 on top and X on top. And 18 is green and it matches with 84. And 98 is purple and he matches with X. So we're going to do this and then go ahead and cross. Multiply that. So we get 18 times 98. So we get 1764 is equal to 84x. And then when I divide those by 84, I get x equals 21. All right, I want you guys to go ahead and pause the video. Actually, I'm going to stop this recording and I'm going to have you guys work individually, independently on C and D. And then we'll talk a little bit about some of the rest of them. But I want you guys to go ahead and work on the rest of the problems. And we'll talk a little bit about G and H together. So go ahead and do C, D, E, and F and rejoin the video when you have finished those. You can check the notes key to see if you are doing the correct work.